Hi everyone, we are Team YYDS, and my name is Jessie.
I'm Chen.
I'm Lucas.
And our project is heart disease prediction. First, what is the motivation and what does our project do? Let's see some data facts first. There are about 80 million people die from heart disease each year, and that's around 32% of the deaths around the world. Moreover, one-fifth of the patients didn't even notice it when it happens. If more people among them can predict the potential risks of it, they are more likely to get an early diagnosis and timely treatment. Secondly, the US government spends over $300 billion each year on heart disease. We could have saved a large amount of money on the difficult lab tests and the subsequent healthcare services if we had predicted heart disease cases. Therefore, our project aims to predict the probability of developing heart disease by some supervised learning classifiers such as k-nearest neighbor, support vector machine, random forest, etc. The second part is the methodology. The dataset we use is from UCI, which combines 5 independent datasets and is the largest heart disease dataset so far for research use. It contains 12 columns with 11 features and 1 target variables.
So here are our data pre-processing work. We use two different encoding methods to transform categorical data to numerical. We first use ordinal encoding, which assigns each categorical data to a numerical value. And then we used one-hot encoding, which we transform each categorical data into a binary feature. So before we have 11 features, after one-hot encoding, we have 18 features. And after that, we plot the Pearson correlation map. As we can see from the map, all the correlation value are lower than 0.4. So we decided to keep all the features since there's no significant redundancies. And we used minimax scaler to scale our data since we want to keep the one-hot encoded data as binary, which is 0 and 1. And we split our data into training and testing using the ratio of 7:3. The matrix we're using for our model evaluation, we use accuracy and F1 score, since we want to minimize the number of false negatives, which is critical to our application. We want our model to correctly predict as many heart disease patients as possible. And for model evaluation, we use grid search and cross-validation techniques to tune the hyperparameters for our models. Since our target variable is 0 and 1, we picked 8 models from support vector machine to random forest.
Next, we're moving to the preliminary result of our project. We built in total 8 models, and here is an overview of the accuracy score for all of the models we implemented so far. We can see that logistic regression, k-nearest neighbors, random forest, and support vector machine all achieved 0.88 accuracy or higher. Here is a closer look at the result using grid search CV, where we use cross-validation to tune the best hyperparameter. We can see that most of them have an F1 score higher than 0.9. We achieved very similar accuracy comparing to the same models used on Kaggle, and the best models being random forest, logistic regression, and k-nearest neighbor. The best accuracy found on Kaggle are 0.92 and 0.91 using random forest and CatBoost. For future work, we're going to try out more models, including CatBoost, LightGBM, and XGBoost. For pre-processing, we're going to scale numerical and encoded features separately. We'll also be using AUC and ROC to evaluate our models. That's all for our project presentation. Thank you for listening. Hope you enjoyed it.